Hello everyone, you are welcome to today's lesson, and in today's lesson we are going to have a look at the solution to the assignment that was given in the previous lesson, and the lesson is on polynomial functions. Okay, so I gave you two assignments. The first assignment, okay, was given after taking you through finding the zeros of a polynomial. Okay, so this is what we have there, and that's exactly what you have on your screens. After this, we'll look at what the second assignment. Okay, so solution. So as usual, this is the question. The first thing that you write after reading the question and underlining the salient part, if in here there is no salient part, unless maybe you want to underline zeros for you to know that you are asked to find the zeros. Okay, so now at this point, what do? This is a polynomial, but the polynomial didn't come with a name. So when you have that situation, we are now aware that we'll give it a name. We'll label the polynomial. So we'll let f of x be equal to, someone can choose to write giving this before writing the let. But will advise that you rather start with the let straight away, just as I did in the previous meeting. So f of x is equal to you extra, so you let this. However, for the zeros, you know the condition. Your f of x should be equal to 0. So now your f of x, you know, is this is equal to 0. So this is a cubic equation. And how do you solve cubic equation? Just like quadratic equation, if you can factorize the quadratic side, you factorize and set each of the factors to 0. So the same way, if you can factorize this cubic expression or function or polynomial, you factorize, then you set each of the factors to 0. So at this point, you ask yourself, how do you factorize cubic polynomial? And remember, in one of our lessons, okay, we did that. Okay, so if you still have challenges, okay, go and review that lesson, okay, to better your understanding. So at this point, we will need a factor, at least one factor. Okay, and that factor, we are supposed to feed our function here with a particular value that will give us 0. And that will inform us that we have a factor indirectly. So at this point, how do you pick your set of numbers that you are going to feed? And I said you concentrate first of all on the factors of what? 18. That is your D. So factors of 18 will be your first set of factors. You will have another set of factors which will be the 4. Okay, that is your first set of factors divided by what? The 4. Each of them divided by 4. But here, you only need one, okay, value that when substituted will give you 0 and therefore one factor. So first of all, try dealing with your pretty values in your substitution. And I said I taught you how to use your calculator to do your try and error. So if you feed your calculator with this and you go and do your try and error, 1 will not work, minus 1 will not work. If s is equal to 2, yes, you get 0. So that's the one that you provide, okay, or produce solution or evidence of work for. So if x is equal to 2, f of 2 will be equal to 4 into 2q plus 2 squared, okay, minus 27, okay, into 2 plus 18. And you know, for now you are mature, so don't go and compute this. You know that this will give you 0. Okay, so immediately you substitute, show your substitution, then after that you write 0. You can bring the 0 down here, it doesn't really matter. Okay, so now once you know that f of 2 is giving you 0, then this implies that x minus 2 is a factor. So once you have this linear factor, if you want to get the other factor, which will be quadratic, you divide the given polynomial by this divisor, which is a factor. So you set up your long division, okay, to perform your division. And if you go through your division, which you are experts now, okay, so I won't waste time, okay, doing this. You can do the long division. Okay, is there anyone here who would need, okay, me to walk, okay, him or her through the long division? We are all fine, right?
Yes.
Okay, so you do your long division and you know that you end up getting 0, okay, as your remainder. So instead of writing 0 here, you can use the dash that you have there. So now it means your f of x, your polynomial function, which you represented by f of x, will be equal to, so it will first of all factorize into the divisor times the quotient. So the divisor times the quotient. At normal circumstances, it's supposed to be plus the remainder, but because the remainder is 0, your final result will be the divisor times the quotient. However, you ask yourself, this linear, yes, your factorization here complete. This is linear, you can't factorize. This is quadratic, it's possible you can factorize. So here, what do you do? If factorable, remember I said, okay, how do you determine that a quadratic expression is factorable? Let me see whether what I said in the previous lesson, okay, was well taken. How do you determine that a quadratic expression is factorable? I gave you a simple way to get that, or a clue, before you stress yourself to look for the factors which possibly might not exist. Anyone here to help me answer that question? Okay, remember I said your b squared minus 4ac, what we call our discriminant, okay, should be a perfect square. I'm using PS for perfect square. So you test, but here it will. Okay, so if you do, okay, let's verify and see. B is what? 9. Because A is what? 4, B is 9, and C is minus 9. So we are going to get 9, which is B squared, minus 4. A is what? It's also 4. Okay, so 4AC. C is what? Minus 9. Okay, so this will give us 81, then plus. Someone should do this for us. 16 times 9. I'm waiting. My professors, are you there? I want the class to be interactive.
It was 140.
Come again.
140.
100 and what?
44.
Okay, 144. So if you add this, what do we get? If you add this, what do you... Come again.
225.
225, which obviously is a perfect square. So that should tell you that this is factorable. So you proceed to factorize. However, when factorizing, you have to multiply. Unfortunately here, we cannot factorize straight away because the coefficient of what? X squared, okay, your leading coefficient is not 1. Okay, so you have to multiply 4 and the minus 9. Okay, then look for the factor. So the factorization is done here. Okay, so you come and do your factorization as a rough work. And always, because you push your work to this side, okay, you should always have room here to contain your rough work for this factorization. Okay, and after that rough work, you cancel. Okay, and remember we use the factors here to plus or minus. That will also be a rough work you cancel. Then after that, okay, this becomes the complete factorization of your given polynomial. However, you said for the zeros, your factorization here, which is your polynomial, should be equated to 0. So you equate it to 0, then now you come and set each of the factors to 0. But when you are setting the factors and you are connecting to 0 and you are connecting, you connect, okay, each one with or. So this one or this one is equal to 0 or that. You come and solve for x here, solve for x here, solve for x here. Then you draw your conclusion with the x. Is my point well made, my professors?
Yes.
Okay, very good. So this will be it for the solution to, okay, that particular assignment. Okay, if you don't have any question, then thank you for making, okay, this lesson as a success.